Welcome to an overview of critical chain portfolio management. All outcomes are the result of the actions taken. In order to succeed, every organization, large and small, must take actions today in order to satisfy both the short and long-term needs of the organization. Said differently, to attain more of the organization's goal, both now and in the future, whether that goal is defined in terms of money, readiness, health, education, transportation, housing, and so on. These actions often involve initiating, managing, and completing cross-functional, sometimes cross-business, projects using shared resources at various levels across the organization. Sometimes the very products or service the organization provides are themselves projects, such as buildings, highways, ships, aircraft, maintenance, repair, and overhaul operations, and so on. More often than not, our efforts to build products, develop new products, set up data and information access to support decision-making, improve business performance, acquire new businesses, expand facilities, install equipment, and so forth, are projects to be completed with defined conditions of scope, time, and budget. As such, scope, time, and budget are most clearly defined in the context of the project's objectives, deliverables, and success criteria. Initiating, managing, and completing projects in scope, time, and budget utilizes a workflow management process involving three primary types of actions: planning, scheduling, control. Planning uses the objectives, deliverables, and success criteria as a framework when constructing a project network in which tasks are defined based on the type of work and the type or skill of resource required, with task granularity sufficient to control workflow, not manage work process. Task dependencies are finished to start, key task integrations are defined, and task iterations and task variability are defined in accordance with meeting task completion criteria. Using highly probable task times that account for anticipated variability and aggressive but possible task times that exclude anticipated variability. You might be asking yourself, why is it so important to have a clearer definition of task time and iteration variability? As we move into scheduling and workflow control, task time and iteration variability will be two of the key elements used in determining time delays in task completion and workflow that need to be accounted for, buffered against, to ensure that the desired scope, time, and budget outcomes are achieved. Task completion variability will be monitored through regularly reported task time remaining updates in order to provide visibility of potentially problematic task completion delays with time for proactive interventions and focus for resource mentoring. Potentially problematic task completion delays will be made visible during execution using decreasing size buffer management to monitor predicted time buffer remaining in relationship to planned time buffer remaining, which we will come to later on. Scheduling of a single project uses information gathered in the project network, along with the total number of resources of each resource type in the portfolio pool, to determine the longest path of task and resource dependencies that will be designated as the critical chain. The project's critical chain workflow will be used to coordinate the workflow of all critical chain-related feeding paths. Task level safety, highly probable times minus aggressive but possible times, related to task time and iteration variability, is repositioned to protect the critical chain with feeding buffers and the project completion date with a project buffer to ensure task completion delays do not impact scope, time, and budget outcomes. The resulting critical chain, with properly positioned and sized project and feeding buffers, is called the critical chain schedule. In a portfolio of projects, using a pool of shared resources, it's unlikely that the capacity of many, if any of the resource types, will limit concurrent workflow within a single project, as is not the case across a portfolio of projects. Scheduling multiple projects across a pool of shared resources is called synchronization and requires individual project starts to be staggered to level the workload on limited or scarce resource types. Staggering project starts means work is scheduled to be started only as early as necessary rather than as soon as possible, which reduces scheduled resource contention. Workload leveling of limited or scarce resources is based on the aggressive but possible load level, which equates to less than 100% of available capacity, whereas the highly probable load level would equate more closely to 100% of available capacity. Synchronization is generally accomplished by level loading a more heavily loaded resource that is shared across all projects in the portfolio. On occasion, scheduling an integration or phase of work that impacts workflow across limited resource types can also be used for level loading, hence synchronization. And in certain circumstances, the number of concurrent projects being worked on in a specific type of work can prove to be an effective mechanism for level loading limited resource types, providing effective synchronization. Each approach provides a different means for synchronization, with one likely being more effective than the others in any given environment. In summary, synchronized critical chain schedules reduce resource contention to the level that repositioned safety can absorb any remaining scheduled overloads without significant impact on scope, time, and budget outcomes, thus providing management with the three essential elements of project control during scheduling: project status, task execution priorities, and resource loading status. With scheduling complete, we are now in a position to put our full attention on control. A typical process for management control includes the following steps. Actual performance is compared with planned performance. The differences between the two is measured. Causes contributing to the difference are identified, and corrective action is taken to eliminate or minimize the difference. During schedule execution, regularly reported task time remaining updates are used to determine if predicted task completions will result in over or under consumption of safety and the resulting impact on project completion dates. This provides real-time project status for all projects and task execution priorities tied directly to project status in terms of predicted time buffer remaining in relationship to planned time buffer remaining. Given that task time remaining updates are occurring in real time while tasks are still active, active task completion delays are directly connected to project completion date impact, thus providing for more effective proactive recovery actions when required. Regular reporting of active task time remaining updates also enables shifts in resource loading to be computed and execution resource contention issues to be identified and addressed in advance of occurrence, thus providing management with the three essential elements of project control during execution: project status, task execution priorities, resource loading status. That is critical chain portfolio management. Given that outcomes are the result of actions taken, we now need to look at some of the required actions for critical chain portfolio management to be effective. Aligning actions to outcomes with regard to projects involves leadership, project managers, resources, and task managers. Leadership's role is to set expectations for aligning actions across the organization with regard to establishing project commitment dates based on synchronized, staggered, feasible, and immune, properly buffered critical chain schedules, ensuring project and feeding buffers are properly positioned and sized, utilizing decreasing size buffer management to define buffer recovery planning and action thresholds, using decreasing size buffer management task execution priorities when assigning tasks or resources, being sure resources are assigned only one task at a time and no switching between tasks occurs, utilizing predicted ABP resource loading to monitor and address resource loading during scheduling and execution, ensuring ABP task time remaining updates based on expected variability are provided for all active tasks on a regular basis, and that resource managers utilize the same information to mentor their resources. Finding other productive, skill enhancement type work for resources during workflow-induced downtimes, times when no task work is available to be assigned, thus reinforcing the benefits of protective capacity in terms of delivering projects that meet scope, time, and budget outcomes. Other productive work is better than starting work earlier than necessary, which only creates additional resource contention issues leading to workflow-induced downtime somewhere else. Being proactive is more effective than being reactive when it comes to the inclusion of protective capacity. Resources working in a relay runner manner on assigned tasks, ensuring safety and quality while endeavoring to meet task completion criteria with the best task completion times possible. Rewarding the actions, not the date. Understanding that task utilization is a better measure of productivity than resource utilization when it comes to delivering scope, time, and budget outcomes. While all of the actions listed here represent a new paradigm in which to manage workflow and resources, staggering project starts and the proactive inclusion of protective capacity to accommodate workflow-induced downtime could most certainly be viewed as a culture change. With that said, critical chain portfolio management is the most effective workflow management method for projects of all types in terms of delivering scope, time, and budget outcomes or bottom-line performance. Transform the actions, transform performance. For more information, please contact us at info@goldratt.com or 203-624-9026. To learn more, read Hanging Fire or attend a Hanging Fire workshop or Jonah Program, or simply visit us at www.goldratt.com. Thank you for your time.